Hello, today we are going to learn about functions. So we've got our foldable here, and I've added the word functions here to my covered page. So I flipped my covered page, and a relation is my vocabulary word here, is a set of ordered pairs, and it shows how numbers are related. A domain is the x-coordinate in an ordered pair. It is the first number or the left number in the ordered pair. It is the input, which means it's 0, 1, 3, and 5. So this is set notation right here, these little braces. So I would write my domain set 0, 1, 3, and 5. And these individual little guys are called an element. These are each element inside the set. Then my range would be the y-coordinate in an ordered pair, which is the second number or the right number in an ordered pair. It is the output, which in this one would be 0, 2, 5, and 3. So writing that in set notation would be 0, 2, 5, and 3. So this is the range set, 0, 2, 5, and 3, and each of these little guys are called an element. And this whole thing is a set. A function is a special kind of relation where there is one output for each input. The domain, or the x, or the input, that's never ever repeated. The range can do whatever it wants. Domain is the one that we have to pay attention to. So looking at ordered pairs, I look at my domain. For this relation, my domain is 1, 2, 3, and 1. So right here, 1 repeats, the domain element 1 repeats, so this is a relation only. B, my domain is 7, negative 1, 2, and 2. And because my domain element 2 repeats, this is a relation only. Down here, these two examples for function. 2, 0, 4, 3. My domain set is 2, 0, 4, 3. My domains are different. It's a function. This example, negative 3, negative 1, 2, and 0. My domains are negative 3, negative 1, 2, 0. My domains are different. It is a function. My domain repeats at any time. It is a relation. Domain repeats relation. I need to go back to function page. Forgot to show you this image. If this is a box of relations, all relations would fit inside this box. And then functions is a special kind of relation that fits inside the big box of relations. So all functions are relations, but only just a few special relations are functions. So that's what we're looking at, determining what's a function and what's just a relation. Going to skip to tables. All we need to look at is our domain. So on this one, my domain element 5 repeats. So it is a relation. If I wrote it as a set, it would be 5, 4, 5, and -2. So 5 repeats. So looking at the second table that goes sideways, here's my domain. Writing it as a set, 0, 5, 10, 15. My domains are different. It's a function. Looking at this last example for tables, my domain would be -10, -8, 5, and 0. My domains are different. It's a function. For a map, this is a mapping diagram. Your domain or your X or your input, these are all the same things, they will be on the left side. Your range, output, or your Y will be on your right side. Now what you're going to look for, you're still looking for domains are different. It's a function. Or if those domains repeat, it's a relation. Now on a mapping diagram, the way you determine if it's repeating or not is if it has more than one arrow from the domain. You're going to be looking for this. So I'm drawing little eyeballs. Look for this. If you see more than one arrow from a domain, it's a relation. So looking at this one, right here, this domain has this arrow and this arrow going to different outputs. This is a relation. This domain, 1, has 2 arrows to different outputs, 12 and 16. This is a relation. Also because the input 4 has different outputs, 24 and 18. Looking at my domain side, cover up the range if you need to. I have 1 arrow from each domain. This is a function. They can go crisscross applesauce, but each one of my domains only has 1 arrow, so this is a function. Looking at this, each domain has 1 arrow. This is a function.